my amazing Algebra 1 students. This is Mrs. A, and I love math. And tonight we're doing lesson 102 in our Saxon Orange book, and we're talking about absolute value inequalities. We talked about absolute values earlier in the book, but we're going to do a brief review. An absolute value is how far a number is from 0. So 3 and -3 are opposite of each other, and both are 3 steps from 0. So it doesn't matter whether you say absolute value of 3, you're going to get 3, or absolute value of -3, you're also going to get 3, because both 3 and -3 are 3 steps from 0. Okay, now your book gives you a more formal definition of absolute value, which you can tuck away. If you know this, now when you get to variables, you do have to understand this here. But right now we're not doing variable absolute values, but let's look. If x is greater than 0, well, we are doing variables, but you can do it without these. You can do it understanding this, but let's go ahead and look at these. If x is greater than 0, which means x is positive, then the absolute value of that x is going to be x. If x is 0, 0 is 0 steps from 0, so the absolute value of x is 0. And if x is less than 0, it means that x is negative, and the absolute value of a negative number will be its opposite. So boils down to absolute values are always positive or 0. Okay, so when we're looking at this, we're looking at absolute value is either going to be a positive number or 0. You're never going to have a negative number as an absolute value. So now we're going to look at absolute values with inequalities. So here we are with our first practice problem, and the absolute value of x is greater than 2. Now our trick is to find out what is x. Okay, so we have to give all the possible values of x that will make this a true statement. So if the absolute value of x is greater than 2, that means if x were positive, x would be greater than 2, and it would go all the way this way. But what if x were negative? If x were negative, the absolute value would swing it over here to this side. Now, if we took this over here and we mapped it backwards, we'd say, well, what if x was in this region over here, less than -2? Well, if it was a -2, it would be mapped over here to a 2. If it was a -3, it would be mapped over here to a +3, and any number in between. So when we have a greater than, it's always going to look like this on the outsides. Okay, you see how this is going out to the outside and this is going to the out, and it's split. So outside and split. Okay, that's what a greater than looks like. And the absolute value of x is greater than 2. Okay, so now we have a second example. The absolute value of x is less than or equal to 3. Well, because there's an equal, 3 is actually one of the solutions. So we're going to put a darkened circle on 3, but now the absolute value of x is less than 3. So if this was a positive number, then we'd be talking about this area right in here. But then if x is a negative number, the absolute value would swing it over. So this from -3 to +3 is going to be our solution. Now let's check it. If I throw in a -3, the absolute value of -3 is 3 because of the equal sign. That works. If I put in a 3, the absolute value of 3 is 3 because of the equal sign. It works. If I put in a -2, which is right here, -2, the absolute value of -2 is +2, and 2 is less than 3. If I plug in a +2, the absolute value of 2 is +2, and 2 is less than 3. And the same with -1 and 1. The absolute value of 0 is 0, and 0 is less than 3. So guess what? This is the region. It's between. So when we have a less than 3, it's between two numbers. The opposites, between the opposites. This one's a little tricky. This one is a less than, so according to the last problem, it should be between two numbers, but it's tricky because the absolute value cannot be less than a negative number because the absolute value is always a positive number. Therefore, no x's would make that true, so no solution. Isn't that tricky? This one's also tricky. The absolute value of x is greater than a negative 4. Well, guess what? The absolute value of an x is always going to be positive or 0. Every number that is positive or 0 will be greater than a negative 4. Therefore, it does not matter at all what you put in for x. It will always have an absolute value greater than a negative 4. Therefore, this solution is all real numbers. All real numbers could be put in for x. Okay, so on this one we have negative, the absolute value of x, is greater than or equal to negative 3. Well, we don't want a negative absolute value, so we're going to multiply both sides by a negative 1. But when we do that, don't you remember that our sign, our inequality sign, must flip around to make the inequality true. Now remember the reason that happened. If I said 5 is less than 6, you would say, yes, Miss A, of course 5 is less than 6. But if I multiplied both of those by a negative, I'd have negative 5, negative 6. Negative 5 is greater than negative 6. So we would have to flip the sign around to make it true. Anytime we multiply by a negative on both sides of the inequality, we must flip that sign around. So now we're going to do the same thing here. We're going to multiply by a negative 1 on both sides to get rid of the negative absolute value. When I multiply this one by a negative 1, I just get absolute value of x. I'm going to flip the sign to maintain the truth of the statement. Negative 3 times negative 1 is 3, and absolute value of x is less than a positive 3, means between two numbers. So I'm going to graph that as negative 3 to positive 3, going in between the two. And because of the equal sign, I include the negative 3, and I include the positive 3. It's as easy as that. All right, so here's our last example, and then we have 2 practice problems, and we'll be done. So here we have a negative absolute value of x minus 2 is greater than negative 5. Now that's really confusing. We want to only have the absolute value on one side, so I'm going to just add a 2 and add a 2 to each side. Okay, so now we have negative absolute value of x. This cancels, greater than a negative 3. So we have not done any multiplying yet. Okay, remember we can add and subtract all day and not have to worry about that inequality sign. So now I'm going to worry about the inequality sign because I'm going to multiply by negative 1 on both sides, which means I must flip. So I multiply this one by negative 1, I get absolute value of x. I flip the sign around and I multiply this one by negative 1, and I get absolute value of x is less than 3. Less than is between again, but it's now less than, so we're going to have an open circle on 3, open circle on negative 3, and graphed in between. So that is the last example. Okay, here's your first practice problem of 2. So we've got negative absolute value of x minus 9 is greater than negative 11. So we want to get rid of the minus 9. Let's add a 9 to both sides to clean it up a little bit. So we get negative absolute value of x. This cancels, greater than negative 2. So now we're going to multiply both sides by negative 2 and flip this sign around when we do it. So we multiply this one by a negative 1, we get absolute value of x. And we flip the sign to a less than, and then we have the the negative 2 times a negative 1 is a positive 2. So we get the absolute value of x is less than 2. Less than, a positive number, means in between. So we're going to put down a 2 and a -2. And we're going to have the line of possible solutions going right in between the two. Oh, and they gave us a very easy one to finish up on. The absolute value of x is greater than 0. Yes, the absolute value of x is greater than 0 for any x that is not 0. So we would say, in other words, if x was negative, its absolute value would be positive. If x was positive, its absolute value will be positive. But if x is 0, the absolute value is 0. So we would say this one would be all real numbers. We'll just put numbers. X does not equal 0. So basically, that's one way you could write it. If you were going to write it in set notation, I'm going to teach you a little bit here. We would go -infinity to 0. This is our interval notation. Then I'll say it in set notation. And then we would exclude 0, union, show you some of the ways that you're going to learn how to write this. That's one way to write all real numbers except for 0. Another way would be in set notation. This is called interval notation. In set notation, we would say x such that x is an element of the real, comma, x does not equal 0. That would be the right way to say it with set notation, interval notation. These are just two things that you're going to be learning, and so I'm just introducing them to you. You don't have a test on that yet. Well, we have finished lesson 102, so have a good time doing your homework. This is Mrs. A. May God bless your day.